Hello, welcome to our 10:30 press conference, Global Air Quality, the Impacts of People and Cities. Our speakers are Bryan Duncan, atmospheric scientist and deputy project scientist for the AURA mission, NASA Goddard Space Flight Center, and Thompson, chief scientist for atmospheric chemistry at NASA Goddard, and Russ Dickerson, professor of atmospheric and oceanic science at the University of Maryland.
Okay, welcome. So we're going to present some satellite images of one air pollutant, nitrogen dioxide, and we'll show that levels of this air pollutant change quite dramatically over the last decade. So first of all, what is nitrogen dioxide? It's emitted when we burn anything like coal or gasoline, so it's coming out of our tailpipes and our smokestacks. It's unhealthy debris, so it's an air pollutant. But more importantly, it leads to the production of ground level ozone in our cities, which is also an air pollutant. And it has adverse effects on biodiversity as well as our water quality. Sometimes in this presentation you might hear us refer to nitrogen dioxide by its chemical formula NO2, so don't be confused by that. So the images that we'll show today are from the Ozone Monitoring Instrument, or we affectionately refer to it as OMI. It is on board of the NASA AURA satellite, which you see here. OMI is a contribution from the Netherlands and Finland to the AURA mission, and I'm happy to report that it's still going very strong, still collecting data, good data. AURA was launched in 2004, so that means we have a decade's worth of data now. So here's an animation of the changes over the last decade, going from 2005 to 2014. The red colors indicate the highest levels, and the blues indicate the lowest levels. The yellows indicate moderate levels in between. And just to be clear, there is no significance in our color choices. For instance, the reds do not mean hazardous levels. However, some cities do have hazardous level of NO2. Next, we'll be showing a series of 5 images. They're outlined here: the U.S., Europe, the Middle East, Asia, and South Africa. The blues indicate decreases. So what we're seeing here are changes over time from 2005 to 2014. The blues indicate decreases. So the levels in 2014 were lower than in 2005. The reds indicate increases, such as over East Asia. And the beigeish areas indicate no change or a very small change. But before we get to these images, I want to say what's new about our work. The data are of such high quality now that we can actually look at nitrogen dioxide levels on a very high spatial resolution, the highest to date. And this high spatial resolution allows us to zoom into cities, for instance, and look at spatial changes in the pollution within urban areas. And in our analysis, we found incredible changes in NO2 in cities and regions everywhere we looked. And this indicates that the human race is keeping very busy, either polluting more or cleaning up a bit. One thing that we found is that changes in air pollutions are an approximate indicator of the stages of economic development. For instance, in the post-industrial societies like the U.S., Japan, and Western Europe, environmental regulations led to decreases of the blue areas. And in China, it's a highly industrialized country. It's the world's manufacturing hub. And we saw large increases in air pollution there, the reds. But there were notable decreases in some Chinese cities. And then in rapidly industrializing countries such as South Asia, like India, the economies are booming, the standard of living is improving, and their air quality is degrading, unfortunately. So our first image will be of East Asia. And of course, your eye is drawn immediately to the hot spot here, the red areas. That is the highly industrialized North China Plain. Nitrogen dioxide levels increased by about 20 to 50% over the last decade. And the reason for this is that China's economic growth is being fueled by its cheap and abundant coal. And one thing you'll notice is that some Chinese cities show decreases, and that's because a growing middle class is now starting to demand cleaner air. For instance, if you look at Beijing in the north, Shanghai along the coast, central coast, and cities of the Pearl River Delta, including Hong Kong and Guangzhou, levels have been decreasing up to 40% in some cases. You also see decreases over Taiwan. And this is occurring because of local governments and regional governments working together to reduce their air pollution, improve their air quality. You also see on this graph some major decreases over South Korea, particularly Seoul, and also over many cities of Japan, and that's because of nationwide environmental controls being implemented in those countries. One thing that's a little more subtle on this map are the increases, or the reds, over the Yellow Sea between China and the Korean Peninsula. And this is indicating that the pollution from China is moving in the wind out over the ocean, and it's impacting the Korean Peninsula and probably Western Japan as well. And this is most easily seen over Korea. I know it's a little difficult to see on this map over North Korea. This is a country that has very low NOx emissions, or nitrogen dioxide emissions. However, their levels have been going up, increasing over the last decade. Okay, next I will turn it over to Dr. Ann Thompson, and she will talk about Europe.
Thank you, Bryan. So we're going to go from East Asia and those deep red colors around to the west and look at Western Europe here. So most of Europe then comes out, as mentioned by Bryan Duncan, because of environmental regulations, principally on mobile sources, meaning cars and trucks, and sometimes ships and trains. There has been a cleanup in nitrogen dioxide. So you can see a number of cities, some familiar to you. I've marked a few others as well, but you certainly can see over the U.K., the London area. You can see Paris. You can pick out Paris. You can pick out Belgium, Netherlands, and the large cities there. And throughout the more western parts of Europe, significant decreases in NO2. This also has translated into moderations in the level of ozone. Madrid pops out. What you may be less familiar with is the northwestern part of Spain has a decline because this is a region of coal-fired power plants, and coal and power plants, unless it's we say scrubbed out by something that removes the nitrogen dioxide, will lead to high levels of nitrogen dioxide visible from the satellite. So there's a cleanup. The largest one is in this region marked Po Valley. It is a heavily industrialized area in northern Italy. Hundreds of papers have been written about Po Valley pollution over the last 40 or 50 years, and efforts to clean up there have really paid off. You can also see the topography there. It's squeezed in by the Alps, so that has made cleaning up that region particularly challenging. There may be, in addition to regulations, a second reason for some of the decreases that we see. For example, Athens has pointed out this 10-year period that we're looking at from 2005 through 2014, kind of in the middle of it, it was the Great Recession, and some of these areas, particularly around the Mediterranean, were hit very, very hard. So there may be not just the success story of environmental cleanup, but also unanticipated benefits of something that for the most part was a hardship. Moscow is on here. This is the first time we've actually seen or really looked at Moscow. A benefit, as Dr. Duncan mentioned, of having this high resolution data. Now let's get closer to home. These are our changes at high resolution over the United States. And you can just about pick any one of your favorite cities. Los Angeles is very prominent there as a big cleanup. The scale, by the way, is absolute decreases in nitrogen dioxide, so the numbers may not mean anything to you, except that the scale here is that this one is about half again as large, is covering half again as large a scale as Europe. So the cleanups here have been pretty amazing. So almost any of your cities, you can see Phoenix, you can see where we are in San Francisco, you can see Denver, Salt Lake, take a look at Chicago. And then, of course, the very highly concentrated and relatively industrialized eastern U.S. So the I-95 corridor, cleanups of cars, trucks, trains, and as well, if you look along the Ohio River Valley, that is another region of power plants. Very high concentration of power plants that have burned dirty coal. Now they've been forced by regulations to clean up. We're seeing the benefits up to 50% over some of these regions, translating to about a 15 or 20% cleanup in the ozone, getting some of our cities just about to the acceptable compliance level of the EPA. So there is one exception you couldn't see in the last map. Let's zoom in now on two other regions. What is illustrated here, now you see the orange. So this is the percentage scale again. So again, the blue is cleanup. So that's North Dakota in the upper left, and its capital is, like most other cities, denoting a decrease in nitrogen dioxide. And but to the west, to a relatively unpopulated region of North Dakota, is the region of intense, during this past 10 years, 5 years in particular, oil and natural gas excavation, exploration activity, a lot of it with these non-traditional methods. You know, we use the term fracking. So what's causing that increase in the nitrogen dioxide? Two things. One is simply the heavy machinery, the trucks and all sorts of vehicles and other motorized things that are used in oil and natural gas extraction, that much of it diesel fuel, going to be emitting large amounts of nitrogen dioxide. The other thing that happens is that not everything that is extracted or that people are finding under the ground is something that they want. And in a region like western North Dakota, this is the Bakken Shale region, if they don't want something, and a lot of the methane is not necessarily what they're after, it may be the petroleum they flare. So on the right side, this is a view from the VIIRS instrument on another satellite, the SUMI NPP, and what you can see the little corresponding lights of Bismarck, but you can see that vast region of the Bakken, exactly where the nitrogen dioxide is increasing, that represents this flaring activity. And in the lower panel, the same thing with the less populated areas of the new oil and natural gas activity in Texas. You can see, again, cleanup in Houston, Dallas, Fort Worth, even El Paso over there on the west. But in the Permian Basin and in the Eagle Ford Shale, corresponding, again, to what we can see from the flares with the VIIRS instrument, those are the circles on the right, they're responsible for the increase in nitrogen dioxide in this region. Now, the next example that I want to show you, if you hearken back to the first image that Dr. Duncan showed, everybody's eyes were fixated, I'm sure, on the northern hemisphere. There's one and only one real red hotspot in our original coloring for the southern hemisphere, and it is the region referred to as the industrial highveld of South Africa. It's a region very well known for having a high concentration of coal-fired power plants, and from the first satellites, which were much fuzzier compared to what we have today, it caught attention. So with this extra high density data, we can see something that we wouldn't have been able to see even a few years ago. You can see here the changes. The orange, the redder color in the lower left is the increase, but you can see that it's interspersed with regions of decrease, and they're labeled on the right side. So the Johannesburg, Pretoria mega city, if you will, which is just full of cars, trucks, and freeways just like ours, has put into place strict regulations on mobile, what we call mobile sources. I've actually spent a lot of time working in this region and visiting over the last 2 decades, so I can tell you that visibly one can really see the change in the car and truck fleet. And so that's blue, that's a cleanup. And some of these power plant regions, the individual ones are circled, and the changes almost down to the individual source are actually visible with this high density product. So some of these are also decreases. Now, there may be a couple of causes, because getting the detailed economic information Dr. Duncan mentioned, this is one thing we can infer from these high resolution maps, is what's really going on in terms of energy and other economic activity. It does appear that there's a cleanup of some of these power plants, but we don't have any figures on that. But another factor in the past 10 years has been that South Africa, like many other global economies, has had boom and bust periods. I was there earlier this year, and there were almost daily, rolling blackouts of several hours per day when there was not electricity available. So there may actually be periods of unwanted decreases in actually doing the burning, and some of these power plants are old, the infrastructure is old. So why a few spots, plants that seem to be increasing in nitrogen dioxide? Well, some of these were deactivated, and the newest plants that are in construction haven't started up again, and so they've been reactivated. So we can see, again, with these new products, an interesting story that really comes down to the level of individual sources. And I'm going to call on Professor Dickerson to take us to the Middle East.
Good morning. I'm not a co-author on this particular paper, but one of many enthusiastic users of these beautiful NASA data sets, a lovely example of international cooperation to help us understand what's going on in our atmosphere. You've heard some good news. For example, the nitrogen dioxide concentrations over much of the developing world, especially the East Coast, where I come from, have improved. We're on a good glide path toward achieving the standards for ozone, including the new standard for 70 parts per billion. The Chesapeake Bay is seeing improvements. Rockfish and oysters are even coming back. So there's a lot of good news to be seen. Also, here is an image of the Mideast, and you can see some substantial increases. These are probably related to the economic growth that has happened over the past decade in Iraq and Iran. After the war in Iraq, the economy was depressed, but the GDP has nearly doubled over the past decade. So you can see development, the restarting of the oil fields, more industrial activity, more transportation. You see some increases in that part of the world. On the other hand, we can take a close-up of this is Syria, and we see some substantial improvements there. But these improvements are a bit like having lost weight because you've contracted cholera. Nearly half of the population of Syria has been displaced. 1.7 million people. Let's see. Well, I don't see a pointer, but you can see the southwest part of Turkey has seen increases north of Aleppo. That's because of the emigration from Syria up into that part of Turkey. Also, about 1.2 million people have moved into to Lebanon, where presumably increases in traffic have caused an increase there that balances the decrease seen in around Damascus. So, in summary, this is a spectacular data set. It's extremely useful for understanding the impact of anthropogenic emissions on global climate, global habitability, global cycles of nitrogen. We've seen broad decreases over most of the developed world, a mixed series of increases and decreases over much of the developing world. I think what we're learning is there appears to be a necessary hump you have to get over. In other words, there's a certain level of economic development necessary before nations decide that they can afford or they want to implement air pollution control. A number of nations have made a conscious choice to expand electrification. Not having electricity is very bad for public health. So they made the conscious choice to electrify without necessarily putting on scrubbers. But I think as the economic development improves, we'll see some improvements in that way as well. So the take-home message is that this new high-resolution data set is something that NASA and our colleagues in Finland and Holland should be very proud of, and it's given us a lot of useful information. We've seen big improvements, but we still have miles to go before we sleep.
Thank you. Okay.
Okay, I just want to say one more thing is you can download this data from these websites, and I ask you to check out our air quality website, airquality.gsfc.nasa.gov. You can download the images for 195 cities and a number of regions around the world. Before we go to questions, I would like to point to two people. There's two additional people in the audience that would like to answer your questions as well. Dr. Pieternel Leveld. She is from the Royal Dutch Meteorological Institute, and Omi is her baby. She's a principal investigator. She's very proud, and she'll be happy to talk about it. We also have Dr. Volker Boersma. He's responsible for the data that we've seen today, in addition to other people like Lamsaw, who may be here. But Dr. Boersma is also a scientist that uses the data in his research, so he may provide additional insights on some world regions.
Great, thank you. Are there any questions from any reporters in the room? And just a reminder that only members of the media can ask questions during the press conference. So any questions from any reporters? And please state your name and affiliation.
Thank you, Jonathan Amos, BBC. I mean, all the trajectories are very good in these places like Europe and the US and all the rest of it. I guess it's important to state that on days, they're still breaking local regulations in those places. I mean, I'm a London boy, and I know how bad the pollution is on Oxford Street, which is way above what the EU requires cities to meet. So, I mean, although there's plenty of blue showing a good trend, there's still some way to go, even in those places that are improving.
Yes, definitely, that is the case. So just because an area has improved, such as the U.S., our ozone is still a major issue. And as Russ said, we have many miles to go before we sleep, the same in Western Europe as well.
Are there any other questions in the room?
Liz O'Connell, Frontier Scientist. It looks like there's no data coming from the Arctic where there's a lot of oil and gas development.
Okay, maybe we can have Dr. Boersma answer this one.
Well, in principle, there are measurements also over the Arctic regions, but there's a lot of snow and ice coverage over there, and that's basically why the measurements suffer from larger errors. On top of that, the satellite measurements only work if you have sunlight reflected, so that means that we do not have any winter measurements over the Arctic. So we could do a trend analysis, but based on not so reliable data that's only available in summertime. So that's the reason why basically the polar regions are not shown in these maps. Yeah, that's true. But yeah, it hasn't been included for this reason in this data set. Because the data is, we think it needs more adjustment and retrieval improvements before we can make them useful for analysis to see if this is actually increasing the NO2 amounts over the Arctic.
And do we have any questions on the chat?
This is from Harvey Leifert. For Dr. Duncan, do I understand correctly that a dark blue area may still have worse pollution than a bright red area, since both start from different levels of pollution?
Yes, that's the case. Yes. Is there a particular area that he referred to?
While we're waiting for that, is there anyone else in the room who has any other questions? Any reporters in the room? We're waiting for that. And, okay. We'll give it a second. I think he's typing.
No particular area.
Okay.
After that. Okay. That concludes our press conference. Thank you very much. And our next briefing will be at 11:30. Methane from hydraulic fracturing. Where does it come from?
I was like.